5:02. I'm not here, and I'm going to put this on here so you guys can have it. You can take notes. That way we can kind of keep going even though I'm not here. This is going to be the last set of notes that we take before our test here coming up. And I would label this 2.8 cell compartments. And again, you remember cells have membranes that allow them to establish and maintain internal environments that are different from their external. So in other words, what that means is whatever's going on in that cell, they don't want it to get out, or whatever's happening outside the cell, that membrane is going to protect it so it won't get inside and mess up the cell. And cells come compartmentalized, right? They have compartments where certain things happen in that certain area. Think of your house. Your house, it's got the outside walls that protects us from the elements. So if it's raining or snowing or big blizzard out or really cold or really hot, we're kind of protected. But yet the house has different rooms in it, compartments. So we have the bedroom compartments where people sleep. We have the bathroom compartments, and you know what happens there. The kitchen, that's for cooking. And you wouldn't want these to all be open in a house. That would not be cool. That would not be very efficient. Wouldn't be a very happy house, if you have your toilet next to your stove. And so we compartmentalize things. That's kind of how our brain works anyway. And so this compartmentalization of a cell makes it more efficient, okay? And I use this, I told you about a house, but you also, planes have compartments. You have avionic compartment. This is where the pilots are. You have the passenger compartment, which is called the fuselage. You have storage compartments underneath. You have the engine compartments out here on the wing. And so if you put them in that particular design, that makes that plane efficient for carrying people, carrying luggage, and things of that nature. Okay, so if we think about a eukaryotic cell, right? You have prokaryotic cells. Prokaryotic cells, even though they're bacteria and they're very small and they still have some compartmentalization in them, but a eukaryotic cell, this is really compartmentalized. And I had you guys take the cards and you memorized all the organelles of it. Those are the compartments that we're going to be talking about, right? So here's your normal, this one here is just a generalized cell. And so you can see it has a nucleus inside there. Remember, that's the control center. What happens here you wouldn't want out here, right? Because in here it stores the DNA. RNA is made, makes ribosomes here. You have your rough endoplasmic reticulum, your smooth. This would be your smooth. This one here doesn't have a Golgi. Remember, the Golgi is it packages the protein, so they're sent. So if it's surrounded by a membrane inside a cell, you can think of a membrane inside of a membrane. That's compartmentalized, and you don't want it to get out. I point this one out. This is a lysosome. Remember, it contains like a hydrolytic liquid and an acid for all intents and purposes, and its job is to digest worn out cell parts, or it may digest like bacteria that have been engulfed if this were a white blood cell. And so you definitely wouldn't want that to leak out in the cell. We know that when a cell commits suicide, apoptosis, it releases the acid and it causes the cell to die. And so you can see that there's just nothing but a bunch of membranes inside of membranes. And what's happening here, we want it to stay here. What's happening here, we want it to stay there. Okay? Now, some things I want to point out. Here's that lysosome I was talking about, and this is that hydrolytic enzyme mixture. Okay, so that's kind of what we're talking about there. I'm not going to talk about it again. And you guys all know that this is the mitochondria, and you notice that it'll have an outer membrane, and then it has an inner membrane. But that inner membrane, right, you can see, remember, it's wavy because we want to increase that surface area. And when we do that, that allows this to make more ATP. And so you have your two layers. And so this is kind of a self-contained organ that creates adenosine triphosphate, ATP. And it's the only one, but you wouldn't want what's happening outside in the cytoplasm to get in here, because it wouldn't be as efficient, wouldn't be as good. And just remember, it's a membrane inside a membrane. And I think that's it. We'll have a test here very soon. And then if you have any questions, you can let me know.